So you're joining us for our second event leading up to our design competition starting in December. At our first event, we had an open house and a workshop where we learned about sustainability, which is our theme this year. We heard from Doug Adams. He's a board member and serves as our county's Director of Research and Development Management. And he encouraged us to be curious and diligent and imaginative when it came to looking for problems that are right here on our island to fix. He wanted us to look at the land, water, food, and energy, and remember that all of these systems belong to a network, and to be mindful of those relationships that are in it and between them. We also heard from Brittany Zimmerman, founder and CEO of Renee, who taught us about life cycles, looking at what happens before and after something as simple as a white t-shirt. She encouraged us to keep asking questions, look deeper, and also be mindful of how processes and resources are connected. So now that we have our environment, our space set up, the world of sustainability, today is going to be about learning what kind of tools to use that you can use to navigate in that space. We're going to start with our design or engineering design process led by Renee Ishisaka. We're going to hear about design thinking from Ravi Pare at OceanIt. And then after our presentations, we're going to talk a little bit more about FishTank, give you an opportunity to ask questions about this year's design competition. Around 10:30 or so, we're going to start our team coordinator orientation led by Lisa Mason. So students, you're dismissed at this time. And if there are any parents or adults in our audience that are interested in becoming a team coordinator for your student teams, please stay on with us. So before we get started, I'd like you to send me some emojis. Let's see how everyone's up, ready for the day. Send me an animal emoji that represents how you're feeling right now. Okay, I want to introduce you to Renee Ishisaka. She is a board director for Next Tech Hawaii. She's also a project engineer from SSFM International, and she'll walk you through our engineering design process.
So thanks for joining us today. We're going to be going over the engineering design process that Next Tech Hawaii uses for FishTank. This is just one of the many tools that you can use, and it doesn't mean that you have to use this and only this, but this is just to give you a starting point in case you need somewhere to start from, and you can work from there. So we use a 7-step design process. So step 1 is understanding the issue. Step 2 is defining a problem statement. Step 3 is to brainstorm your solutions. Step 4 is to design and model those solutions. Step 5 is to test and evaluate those models. 6 is to modify and improve on that design. And 7 is to finally present your solution, which in FishTank, you do a report and you also do a presentation or pitch. So let's get started with step 1. So this year's theme is the UN Sustainability Design Goals. So a good place to start out with that is to understand what those sustainability design goals are. And I believe there's 17, Noel, correct me if I'm wrong. I believe there's 17 of those. So there's lots of different categories to just get an idea of what those are. And then start thinking about how do they apply to Hawaii. And if there's an issue you care about, think about that issue and think about how does that fit into the SDGs and which category that might fit into. Step 2 is to define your problem statement. So the model that we use has 2 different guides. One is saying the affected group needs a way to state, and then you state the need because of, and state the impact on the community. So for example, this could be the Hawaii State DOT needs a way to protect their highway system from sea level rise, because losing use of the highways would have an impact on um, people being able to move from place to place within our islands. Another format of that would be who has the problem of what, when, and where, and my solution will help meet this need how. So I don't have a good solution for this one. So if anybody wants to jump in and offer up an idea of what they have, or if they've been thinking about something, then feel free. Otherwise, trying to take a twist on that first example, it could be the Hawaii State DOT has the problem of some of their highways being inundated with sea level rise. My solution will help meet this need by laying out alternate highway alignments or something to that effect. But basically, the point of the problem statement is for you to focus your idea and use it as a compass to guide you as you're doing your research, so you can return back to what that focus is and you don't get sidetracked and start going in all kinds of different directions. It helps you focus your research and focus your project. Step 3 is to brainstorm a solution. So to start brainstorming your solution, generate as many ideas as you can. One tip is to have several 10 to 15 minute brainstorming sessions. You want to keep these rather short, because otherwise, if you're having trouble generating ideas, you're going to start just beating up on yourself and you're going to get too inside your head. So keep these kind of light and short. Just concentrate on throwing out ideas. There's no wrong idea. So just throw out anything and everything. And then the next step is to narrow those down to about 3 to 5 ideas. And then you're going to analyze those a little bit more in depth. And then ultimately, you're going to choose the solution that you want to pursue for your project. Step 4 is to design and model your solution, or your problem or your solution. So this is your planning phase for your solution. So you got to consider the constraints. So if, for example, you're doing food security, maybe it's what kind of food sources we can sustain on the islands, and then build a model. So this has a bunch of different looks. It can be a conceptual model. It can be something like a step-by-step process. You can build a line diagram. It doesn't have to be the more traditional physical model that you see in a lot of science projects, or you just don't box yourself into thinking that you're overwhelmed because you have to build a physical model, because that's not the case. This can be a 3D model, it can be a CAD model, or it can just be a concept. But the main point is that you want to have this fleshed out and you want to think of all the aspects of it and put something together that can convey what you're thinking of to somebody else. Step 5 is to test and evaluate that model. So you want to think about what works about it and what doesn't. And the more tests you do, the greater it is, because that's that many more constraints that you're dealing with, and that much more executable your design can be in the real world. And that ties into step 6, which is to modify and improve your model. So this is iteration, and this is the main core of the engineering design process. So you test your different scenarios in step 5. You make adjustments. You retest those, make changes to your models, repeat as necessary. So there's no set amount of times that you need to go through the iteration process. But I think as you work in your model or work on your project, you'll find that you kind of this is the fun part of it, where you get to run through it, see what works, see what doesn't, and make it better. And this is really where all the magic happens in the process. And then finally, you have present the solution. So there's many forms to presenting your solution. Just a couple that we talked about for FishTank is your report and your presentation. But it's no matter how you're expressing your solution, it's important to know your audience, because if you're going to be presenting to a room full of children, then it's going to be different than if you're going to be presenting through a room full of adults or a room full of design professionals. So you just want to tailor your presentation to your audience. But no matter how that or who your audience is, you want to explain why your solution works. And while you're doing this, don't forget about your problem statement, because you want your solution to relate to your problem. I'd like to introduce you to Ravi Pare, design thinking strategist at OceanIt, who's going to share some of his ideas with us. Thanks for coming, Raji. He's been a great asset to our design team and our fish tank team, and we're privileged enough for him to lend his expertise to us and help out with this wonderful competition.
Thanks, Renee. Thanks for the invite. It's always a pleasure to be part of this event. It's supporting the younger kids, and yeah. Thank you. Can everybody hear me all right and can see the screen? Okay. Again, and it's going to be a small talk, so feel free to interrupt me anytime and ask me questions. It would be nice to have it as a conversation, right? So, and it was a fantastic story of Richard that Renee just shared. And there are so much correlation to both design thinking process as well as the engineering design process. In some ways, we are all, as we go through our lives, we encounter problems all around us. The moment that you get up in the morning till you sleep, you're always figuring out the world around you. And sometimes we don't look at things as problems, we just work around them. But when there are bigger problems, such as, let's say, lions eating your livestock, right? That keeps you awake all the time. Those are important problems to be solved because it has such a big impact in your community. So you begin to think. But when you have a process, it helps you in very different ways to solve these important and complex problems. Let's walk through some examples. Okay, so again, I work for a company called OceanIt. My background is in design thinking, mechanical engineering, and I would say in all of those disciplines, the key thing that is required that all of us have is curiosity, right? That's the first important ingredient for anything, because if you have curiosity, when you look at a problem, you want to understand more about it, right? You want to know why it is happening. So that curiosity is the key ingredient for anything and everything around you, right? You want to fuel it all the time, because curiosity allows you to ask questions. And with questions, either there comes answers or more questions. Typically, it is more questions, which is actually a good thing, because you can answer them, figure out more and more, and eventually you will find a solution for that. So, okay, let's go through the design thinking process and talk about a bit about the process itself and how it relates to the engineering design process. Let me see here. Let my slides move. Okay, so let me start by sharing another story to add on to Richard's story to see how this engineering design process correlates so much across all different kinds of important problems that we try to solve in the world, right? So here is an example, very different kind of example from a completely different part of the world. So you just went and heard a story from Nairobi. Now this is a story from up near the Arctic Circle in Denmark. Okay, it's a small community of people, and there you have a lot of elderly people in the community. Okay, 125,000 people, a lot of people. But in Denmark, the social systems are really good. They have always taken care of their people. A lot of encouragement by the government. So when somebody gets old, they cannot cook for themselves, or perhaps they are staying by themselves and they cannot take care of themselves. All they have to do is go to the local. Sorry, the slides are not moving right. So they have to just go to the local municipal and write their requirements, saying that, hey, I am diabetic, I need this kind of a food. And the county will just deliver food to them 3 times a day with their nutritional requirement, right? Fantastic system, and it's all paid for. But when they did the survey to see how is the system working, they found out that nearly 60% of the population was not adequately nourished in this elderly population, right? The seniors. And 20% were malnourished. So they were like, what is happening here? Again, they were curious, right? They wanted to find out more. They wanted to understand what is happening here, despite such a good system and the solutions that are out there, which sounds very good. It's not working out, right? So one of the first things that they said, what do you do in the engineering design process? The first thing, you try to understand the issue, right? You try to understand the problem. So in this case, one of the things that you could do, among many other things, to understand the problem. So again, you can feel free to share things, okay? So what do you think are the things that you could do to understand more about the problem? So the first step in the process, right? Understand more about the issues. What are the things that you could try? Talk to people. Okay, that's a very good one, right? What other things would you do? Yeah, feel free to unmute and share, Malcolm. Observe, that's a very good way of doing things.
You can research online too.
Fantastic, right? You can research online. What other things can you do? Yeah.
Going to tell you, I was just going to tell you that I feel like people should be more aware of the superfoods. It's found so easily, and the fact that local food is better because it loses nutritional value in shipping.
That's a very good point, right? So when you want to understand issues, you want to understand all different aspects. Like, for example, the thing that you mentioned, right? Local food is better. Those are interesting aspects that will fuel your understanding of the issue, right? So, for example, you can talk to people, you can speak with professionals, you can read books. I'm seeing the comments here. You can read the books. You can look for other case studies which have been done in the past in other locations or similar projects that have been done. All of this is rich with information, right? You don't want to say, hey, I know the problem, let me solve it my way. You want to explore as much as possible continuously. So you're discovering the issue. So that is what this team did. When they saw this problem, they went and spoke to people. That's the first thing that they did. Not that they did not do other research. They did that as well. Many times in projects, people do research and continue on, right? One of the key elements which fuels innovation is speaking to people and observing them, right? Because people can be this magic ingredient, because eventually your solution has to be used by people, right? Whatever you design and develop, eventually those solutions, if they impact people, they have to use it. So you have to understand things from their point of view, right? You are not solving the problem for yourself, you're solving the problem for others. So in this case, the team went and spoke to the people who are part of this program, who have subscribed for this food service, and they asked them questions. They observed them, they spent time with them, and they learned a lot of things. One of the things that they learned is that, a lot of this the senior folks were lonely. The biggest time that they enjoyed was time spent with their grandkids in the evening, right? So they could share a meal with them, spend time with their grandkids. But once they availed this service with the county, they could not share their food. It was either lacking salt or sugar or in whatever way, right? The kids wouldn't want to enjoy the food with them. And that they missed it. So that's one reason they never even applied for this service, right? So they learned a lot of different things. So they could have, so let's say that they did their research and said that, hey, local food is what will increase the nutritional value. Let's provide them local food. You would have missed these opportunities, such as why some people are not subscribing to this because they cannot enjoy time with their grandkids, right? They understood that by speaking to people and observing them, right? Another thing they learned was that they were not so proud about the fact that they cannot take care of themselves anymore. You had this big truck coming from the municipal saying that there is a municipal food service, right? All of a sudden you had all your neighbors asking, hey, are you all right? Can I help you? That hurt their pride, right? These are the things which are not noticed with just plain research. By talking to people and listening to their stories, you can understand these things at a deeper level and solve for it. So let's see. So one of the first things that they did is they changed the name of the thing, of the entire, instead of having a municipal food service, it was called the Good Kitchen, right? Also, now the elderly folks could even subscribe food for their grandkids. It was not just for them. They could actually order it like a restaurant. They could get food for everybody. And once they launched the food service, they saw that, so eventually they spent about 6 months to develop this solution. They saw that the week they launched this new program, they were 500% increase in subscription. 500%, that's 5 times more people subscribed for the service, right? And not that they were constrained, like some of the things that you think about when you launch programs such as this, can we make it happen? Will there be money? Will there be people supporting these ideas? All of those things are actually secondary. The first thing is the people, right? You are developing the solution for somebody. If they like it and they want it, you can figure out the other pieces later. It's not that it's not important, but you can figure it out later. The most important thing is the people. If you can, most often things fail because the solutions developed were solutions that people did not want or like. So you want to address that in the first place. Okay. So fundamentally, it's about developing solutions that moving away from making people want things to making things that people want. For in the case of Richard, remember the grandmother next to his house also wanted that solution, right? He was not going around and selling that solution, saying, hey, here is the indicating light that I can make for you, you can use it. They just saw the results of it and they wanted it, right? All over Kenya, they wanted it because it was working. It met the needs of the people. And that's what you want to focus on. It's not about making things and selling it. It's about making things that people want, right? Now, okay. So now we saw the engineering design process as relates to design thinking and how you solve problems with this. Let's go with piece by piece, okay? And let's relate to the entire process because these are the steps in the process. How do you do each one of these steps? What are the different things that you can do in each one of these steps so you can increase your chances of creating innovation? So before we jump into the each of these elements, let me tell you about the process itself, right? A process is a magical thing, right? It's a magical thing. When you have a process, it means that you have a pathway or like a map for innovation. It's not just a random idea that comes across, right? It's not that, oh, I'm gardening, I'm running, I'm having a shower and I have a aha moment and idea and solution is done. It doesn't happen that way often. There is a lot of things that goes into creating a fantastic idea and an innovation. In a process, you take a sequence of steps. Step 1, step 2, step 3, step 4, right? In the end, you have innovation, which means that now you have a map for innovation. Not only that, another fantastic benefit of a process is different people can work on different pieces of the steps, right? So let's say Malcolm mentioned that I need some adult advisor help. So let's say that you are very good at understanding the issue. You need some help with prototyping. You can always bring your friend, your parents, or some adult help to make some part of the step. You don't have to do everything on your own, because a lot of complex problems around us, in fact, cannot be solved by a single person. You need a community of people. You need different kinds of skills. And everybody wants to help you once you have the story and understand the people's need, right? So the process is a magical tool. It's also that a process can be learned, a process can be taught, and you can develop your skills in a process, right? If I tell you that, hey, come up with an idea, and you say, I don't know how to come up with an idea, I just say, try harder, think harder. Does that work? No, right? But what you could do is follow a sequence of steps and allow yourself a higher chance of coming up with very good ideas. And you can replicate it in each and every project throughout your life. It's not just for this project, it's for every project that you can take up on. It could be about how do I plant, let's say you want to plant a garden in your house, how do I better plant it with the resources that I have? You could follow the process, right? You could use it for creating a new dish, perhaps. Anything and everything, you can use pieces of the process or the entire process. And hundreds of problems, just like Richard's solutions, hundreds of solutions, in fact, thousands of them around the world has impacted society by using these processes and solving problems like this. I won't go deeply into all of them. Maybe I'll narrate one of them. Is there any favorite thing that you are curious about in this chart? I know there is a lot of things in there. I will share the slide deck. You'll be able to refer to each one of them. But is there anything that interests or captures your mind in this slide? Not that I know about all of them, but tell me if you are interested in any of them. I can elaborate a bit more on that. Yes, Penelope.
I see a bowl in there, and it seems to have a separate bowl with different things inside, and I can't exactly read the script. It's a bit blurry, so I'm kind of interested in what that is.
The bowl with the tomatoes inside, is that the
Yeah.
one? Okay. So that one. So in developing countries, right, you have very hardship for finding electricity. Not like perhaps underdeveloped countries or developing countries. Now things have changed. These are slides from about 10 years ago. This is a center page, I believe, from National Geographic from 2010. So they were talking about social innovations from around the world. So that particular thing is a refrigerator, which is passive. It doesn't need electricity, right? It doesn't need electricity, and it can keep things cool, but not like the freezer thing, right? Not like you cannot store popsicles in it. But people in this part of the world, they're not interested in keeping popsicles. They are interested in keeping their fresh produce from their garden for a longer time, right? So this particular thing is nothing but a terracotta containers, one inside the other, and you fill sand inside and water, and it keeps the center part cooler, right? So when you say, so for example, in this particular example, right, if we, from our perspective, say somebody comes and says that, hey, FishTank community, design us a refrigerator. So what would you do? You'll think about all the experience that we have had with a refrigerator in our lifetime and say that this is what I will make. But when you take it to this country and this community of people, they say, I don't know what to do with this one. I don't have electricity. I don't use the same kinds of things that as you do, right? That's why you want to start by understanding the issue. But imagine if you were to go to visit their houses, talk to them, speak to them, talk story with them, right? And then you understand, hey, their lifestyle is very different. Things that they value is very different. What they want is to retain their tomatoes or cassava or other things for more than a week, because they get to harvest only once a week, perhaps. They get to share it with their neighbors because that's their refrigerator. You share your food with your neighbor, they share their food with their neighbor. Your refrigerator is your neighbor's belly, right? So things like that, you understand stories and interesting aspects, and you develop with what they need, not your solution, but what they need. And you realize that they don't have electricity, but there are many, many things that you can use. You could use water which evaporates. You could use terracotta containers, which are simple. When you break, you replace them. So when you create this solution, understanding all the needs, they want it. You don't have to sell it. It's affordable, right? It's replaceable, and you can use it anywhere. So that's an innovation. So you will find similar stories all around. Maybe they won't scream out saying, hey, we use the design engineering design process or the design thinking process, but they have used those elements in there. They have used that pathway. In the outside, it looks like, hey, they came up with this idea. It was very easy, but they have, wandering around a path, trying to trying to find innovation, right? That's the iterative process. Okay. Again, later if you, I see that there is an electric motorbike. Okay, I will send this link to you. I'll find out the page and send it to you so you can read up on each one of them and you'll find a lot of interesting thoughts and ideas around them. Okay, so let me go to the next slide here. So design thinking process relates very closely to the engineering design process. We'll go through each one of these pieces and I'll walk you through with different tools in each one of those steps. Okay, so the first step is understanding the issue, and you already suggested we should talk to people, observe people, right? Understand, research things. So those are the key things that you want to do in the first step. That is about understanding the issue. So what you do, you speak to people, you observe, engage with them, understand the problem. Right? That's the first step. The second step is defining the problem. Right? You talk to people, understand things, but you still have to define what the problem is, because the problem can be very large. Maybe your teammate is solving a different problem than you, but when you define a problem, all of you are on the same page, right? And the problem, defining the problem can be very simple. It would talk about who you are solving for. That's the person that you are solving for. See, somebody is waiting to enter the room. Okay. Who you are solving for and what do they need. And there is a magical last piece which we often don't think about, which is why do they need it? Right? So who are you solving for? What do they need? And why do they need it? So those are the three things you want to consider. You're not solving for yourself, you're solving for them, for the people that you're developing for. So that's the second step. The third step is very important. It's about generating ideas, right? Thinking about a lot of ideas. Now, you want to think ideas that are very different from each other. So, for example, in Richard's case, the ideas that he had was all very different from each other, right? So one was a scarecrow, one was a light, one was just walking around, right? Or just keeping a light on, like different kinds of things. He had a lot of different ideas which are different from each other, and he could test them out. So one of the things that once you understand the problem, what you want to do is generate a lot of ideas. Those ideas need not be good ideas. You are aiming for a lot of ideas, quantity versus quality, because with quantity, you will get good ideas among them. If you generate 100 ideas, I bet that at least 10 ideas of them are going to be very good. But if you have only one idea and say that, hey, I have one idea, let me go with it, there is a high chance that that may not be the idea that would work. Right? In this stage, you want to generate a lot of ideas. After that, once you generate ideas, you pick some ideas, right, out of that, and you pick ideas that impact the people the most, not the ideas that I can easily make, the ideas that I know will work, but you want to pick ideas that will make your end user, that your user really happy. That's the one that you would work, that they would like and want to use, all right? And you create a prototype. So that is design and model. So you want to create a prototype. So what in your mind is a prototype? Can you think of examples of a prototype? Yes, Malcolm.
Maybe a schematic.
Yeah,
or something like that. Like, and maybe like a wooden model, like to get the basic ideas, but like just a schematic or a SketchUp can work too.
Yeah, that's a very good way of doing it, right? So a prototype is nothing but a representation of an idea, a physical representation if possible, right? So schematic is one, wooden models one, clay model, Play-Doh, cardboard, paper, anything, right? Because you sprinkle some imagination around your prototype, it becomes the final thing almost, because you can share it, you can show it to people and get their feedback, right? And you are not only looking for admiration and feedback saying, hey, you did a fantastic job, this is looks very good. What you are looking for in that prototype is for people to tell, hey, what about this one? Have you thought about this? Have you thought about this one? That is what you should welcome, right? Not saying, hey, I have a prototype, and if everybody says that it's fantastic, it's good, they're probably lying. You should ask them, hey, tell me what is wrong with this, right? Because the intent of a prototype is as a learning tool. It's a stepping stone to develop better ideas, better prototypes. So when somebody says, hey, prototype looks beautiful, no, that's not the intent of a prototype at this stage of the project, right? The intent is to find, you should probe people and the users saying, hey, here is a prototype. What do you think? And they say, I like it. You say, what do you think can be improved on this one? Where do you think it will fail? Right? You want to probe and get more information. So that's the intent. And you see this sentence here, it is most successful when you take these prototypes to the actual people and if they can experience and interact with it. Right? And you can create that in many different ways. So for example, if your solution is I'll take a bland example, it's an app, right? Let's say it's a phone app. You can just create a mock-up in a cardboard and show different things. It need not be an app at all, right? And you can make them experience it without actually creating it. And that's true with a lot of ideas, right? If you want to, let's say, hypothetically speaking, you want to create interesting drive-by farmers market, let's say, right? How would you create a prototype for it? You could create prototypes in various different levels, right? It depends upon what is that you are testing. If you want to test whether people will come to that, if you want to test whether you can make it happen, you can pick and choose what you want to test and make a prototype for it. But the important thing is to create a prototype and learn from it. And that is almost the last part, right? The test and evaluate. When you have a prototype, you're taking it to people, getting their feedback. And most important thing is to modify and improve, right? So it's an iterative process. So you almost, when you take the prototype and show it to the end user and you show it to them and they say, hey, what about this one? What about this one? Now you have a better understanding of the problem itself, right? For example, Richard learned that if something is still, the second day the lion comes, it doesn't care about it. Hey, it's not moving, it's not a person, right? Maybe that triggered this idea of the light it's not sufficient if you just keep a light bulb on, it has to flicker, right? Now his ideas have changed because he has learned from his prototype, right? Every prototype you learn because that's the key element of a prototype. It's a learning tool, not a demonstration tool or an inspiring tool, right? It can be used for all of those things, but that is one thing that we often miss out from it. But the key thing to remember is that it's an iterative process, right? You might, like, for example, Richard, at least he shared 3 or 4 ideas, and I bet you he must have tried 100 different ideas. It may not be the only 3 ideas that he shared on screen, that because it felt like a good story, he shared those 3 things, and I'm sure they tried a lot of different things. So don't be disappointed if the first 3 prototypes that you develop was like, oh, it's not hitting the mark, right? So it's all about developing that curiosity and iteratively moving further. Now, all of these things, the process, design thinking process or the engineering design process, one of the key elements that makes success using those process is the mindset, how you think about it, right? I mentioned about curiosity, right? I'll mention the 2 other important things. One is it's about human-centered. That means that you prioritize people, right? People you are developing things for in your community, perhaps what problems that you're looking at, you are talking to them, understanding the problem from their point of view, not your point of view, from their point of view. So when you make choices, you make choice which is good for people, right? Good for the people. That's always your choice. The second one is collaboration, radical collaboration. That means when you, let's say in my company, right, at OceanIt, let's say that all of us are working on a project and all of us are mechanical engineers. We all think the same way. We all have the same language. Guess what happens to the solution? They all look the same, right? Because we all have the same experience, let's say. Imagine if we have different kinds of people among us, like maybe a team of 5 people. We have a materials engineer, we have a mechanical engineer, we have a linguist, we have a marketing person, we have a teacher. Let's say all of them are coming together. All of them bring very, very rich experiences and perspectives with them. But there is a magical ingredient still. It's not about just having those people, but having a good mode of getting those people to talk to each other in a positive way so that they can build on each other's ideas, right? So that is when the process becomes even more important. So if all of you know that when 5 of these people come together, the intent is to generate as many ideas as possible, you are only focusing on ideas and not debating on whether this idea will work or not, right? So that's why the process gives guidance and the right language for a group of people to come together and build on each other's ideas and develop radical solutions, right? So those are the 2 takeaways, so to say, as a mindset. But you can see that there are more mindsets. but I would say those are the two important ones, right? So any questions, by the way? So I have some more slides, but I would be happy to address any specific questions or other things. Feel free to ask questions or comment from your experiences, perhaps. Anything to share? Okay, maybe I'll move further then. So one of the key elements in any kind of innovation, I think we touched upon this one, right? Make the human element as important as technical and business elements. Now it looks very complex, but it's very simple when you look at it in a different way. For any innovation, right? For any magical thing, innovation that makes a lot of difference, changes lives, there are three things that are important. One is the viability. You should be able to make it happen, right? Viability. That means it should not defy the laws of physics, right? It should be viable. Oh, sorry, that's the feasibility part. It's the technical part, right? Viability is often about, can you make the economics work? So let's say that, I'll give you an example. Let's say that, maybe we'll cover all three and then we'll dive into examples, okay? Viability is about money. Can we make it happen with the money that we have? The third important piece is whether people would want to use it. So you have desirability, if people want to use it. You have feasibility, whether it is possible physically. Then you have viability, which means that can we make the economics work? All three of these things has to work to create a good innovation, right? Now let's talk about examples where one of them is missing. Okay, so let's say helicopters for everybody. Okay, every household has a vertical takeoff machine or a helicopter, and you can say that there would be a lot of people who would want it. Okay, maybe with the current climate situation, maybe not, but let's hypothetically say that everybody wants a vertical takeoff machine in their backyard so they can go to school and back very quickly, right? And it's feasible. Of course, with engineering, you can make it, it's already there. But is it economically possible? No, right? So the one leg is missing. So let's talk about feasibility as a missing link. Let's say we have a teleportation machine. We need a teleportation machine, right? How many of you here need a teleportation machine? Which means that you can go back and forth from Hilo and Honolulu in a second, or anywhere in the world, right? You have a teleportation machine, why not? So yes, all of us need it, right? I would want it. I would rather be in person and speaking to you rather than on Zoom, right? So that's the desirability part of it. The money part of it, yes, I think hundreds of people out there would want to pay for it. It would make economic sense. You don't have to fly anymore. You don't have to spend in airport lines. But is it feasible? It's missing, right? It's not feasible. Maybe in the future, maybe in my lifetime, or maybe in your lifetime, right? You have many more decades after me. So maybe it is possible then. But it's a missing link. Desirability, where you have technically things are possible, business-wise it's possible, but people don't like it. How many of you have seen Segway, the thing that people ride, right? How many people have used it? No, me neither. It doesn't look that desirable. I don't know why, but it is feasible. Technically, it's possible. You don't fall off of the wheel. It's business-wise, it's possible, but people don't like it. People did not use it, right? So it's not an innovation, right? They made it work. It's admirable, but you cannot predict these things. Before you start solving a problem and developing things, it's not possible to predict. The best way to do this is follow the design process, where, like you see the image on the left, where you talk about desirability, feasibility, and viability. I imagine it to be like three legs of a chair. Even if one of them is missing, you cannot balance innovation on the top, right? So you want all three of them to work. And the best way to do it is spend a little time in all of them as you develop it. The interesting thing is many teams around the world, any engineering team or any problem-solving team often spend a lot of time on feasibility and viability, the business aspect and the technical aspect. Many times they miss out on the people aspect, right? Even a tiny amount of time spent early in the project about people will immensely help the success of the project. It's not about just asking people whether you like it, it's actually going deeper than that, understanding why they do what they do, right? And there are many, many tools to do that. The very fact that you are aware of this is a big step, right? That, hey, that is something to be admired, to be talking about people and business and technical aspects. The second element I would talk to you about is collaboration, right? All of this
Hey,
is
Ravi.
right, but
Ravi, Noel here. I just wanted to just go back to the previous slide, and this might relate to our theme for this, for this competition, sustainability. And one of the things I'm looking at is desirability, and a question I would like to ask, and maybe even make the connection for us, is whether or not this covers not only the attractiveness of the solution, to meet the person's or the need, but also to go further and cover what may not actually be stated, right? And what I mean by that is environment. So can desirability cover not only the ability of the solution to meet, or the idea to meet, a social need, but also the need of the environment, to protect the environment? Is that a good way to look at it?
yes, absolutely. Absolutely. In fact, that desirability part is not only the desirability of the end user, but overall well-being of humans itself, right?
Thank you.
So it's so critical, right? And when you talk about desirability, you are talking about from all different stakeholders, and a lot of different kinds of people. Like it's like, in some ways, maybe here is an example of talking about it in a different way. If you are designing a toy for a kid, or maybe a candy for a kid, right? They would always want it, right? It's not to say there is desirability there. You should also look at whether it is healthy for them, whether it's good for them, right? It's the same thing with these solutions as well. Desirability. So it becomes the responsibility of the designer to look at the world in a different way, to say, is it for the betterment of the society, right? Is it good for our environment and the challenges that we face as humanity? Like, be it like big challenges that we see around us, right? These are very, very hard problems. They're called wicked problems, by the way, right? Where forget the solution part, you cannot even define the problem well enough. And everybody has a different opinion on the problem, and how to solve it, what is important. And it's even more important to follow these processes to make it easier to solve them. And thanks, Noel, that's a very important point. We should look at that one too, and it's part of that desirability.
Thank you.
I think almost it relates to this collaboration. Probably we can be looked at it as a desirability part as well, right? In there, that's one of the reasons why you want collaborative effort. So let's say that I am a hardcore engineer and I don't think about the climate at all, but your teammate is a hardcore climate activist. He thinks about it, right? So it's like blind people feeling an elephant. All of us have different perspectives, right? Do you all know the story of the blind people feeling an elephant? Everybody, okay, no, okay, good. So, and let me illustrate it in a very minor way for people who may not be aware of it. So it's a very, very old fable or a story, right? And every community, every culture has a story similar to this one. I am familiar with the one from India, where there is a story, or there is a hymn written in Sanskrit from a long time ago, where they talk about this story, right? What it talks about is there's a group of wise blind men in a village, and they are thrilled to hear that there is an elephant going by near the village the next day. So they all rush to the elephant because they've never felt or known about the elephant. So they all touch the elephant, and the elephant goes away. And then evening they sit around the tree and they're talking about the elephant that they have felt. All of them touched a different piece of a elephant, and they all had very strong opinions about what they touched and what the elephant is. The person who touched the tail knew that it's slender and long with hairy in the end. That's what an elephant is. The person who touched the tusk said it's a hard, sharp thing. That's what an elephant is. The person who touched the belly said that it's a big thing, like flat thing, rough in texture, all those things. They all experienced it, right? That's the truth for them. If I tell you that, hey, what you see is not real, of course I have experience of that is real, right? So they had a big conflict among them. Went on for months. They stopped talking to each other. Then came a wise man, and they asked him, hey, we all have felt this thing. What is real here? So who is right and who is the wise amongst us? So he says that, all of you are right and wrong at the same time, right? All of you are right and wrong at the same time. It's more important. So all of us perceive the truth around us indifferently. But when you put all of our viewpoints together, right, they need not be exclusive, right? Just like if I'm right, it's not to say that you are wrong. Both of us can be right together, right? So you can build on ideas and see the elephant, even if you felt only one piece of it. So, oh, sorry, Malcolm, I see your raised hand now.
It's all a matter of perspective, basically.
Exactly. It's not just true for blind men, right? Even for us, we are blind in many ways because we don't know the world, right? We are only seeing one little piece of the world, and we take our experience to be the truth, the ultimate truth. Let's put it that way, right? But your teammate might have experienced different things. You might have different point of view. Not to say that they are wrong. Even if you have experienced different things, you want to build with each other's ideas, and that's what the process enables you to do things as well. So when you are working and looking for a teammate, don't just look for people who think just like you, right? You want people who have different experiences and different opinions, but you need to build a good way of talking with each other and working on those experiences. Sorry, Malcolm, I see your raised hand again. What's that? Come in, unmute. Yeah.
You need variety in your ideas, because otherwise you won't really be getting anywhere if your first idea doesn't work, if you don't have any more inspiration that's different.
Exactly. So that's the collaboration part of it, right? So that's all. I know I've passed the time limit as well. So those are broadly the elements of the design thinking process and the key takeaway of the mindsets of what you want to include in these projects, or any projects for that matter. Any thoughts or questions? Happy to elaborate on anything, or you can also email or ask questions later. That's also fine.
Hey, Maria, sorry, Ravi, before I answer that, how are we on time? Do we have like a few more minutes to just discuss?
Maybe a few more minutes. We want to
okay.
FishTank a little bit after this, and then we have our
Yeah. So Ravi, one of the things that is one of the things we'd like to be able to emphasize as we're going through our competition is the need to be able to understand and consider. I'm going to try to think of a better way to state this, but it's the consequences, right, of our proposals, right? So if we come up with an idea that that appears to meet whatever the needs are, sometimes it's important to ask questions like, okay, so if we're to do this, what are some of the things that might happen as a result? And if those things that happen as a result are not desirable, what do we do, right? Do we come up with a different design? Do we come up with another thing to make that thing go away? Can you also comment on how that part of problem solving can help our team?
Yeah, absolutely. And I think that's a very important thing, right? Many times, so when you go through the first iteration, let's say, you have very crude prototypes, very, very simple things, which maybe some people like, some people don't like. It's very important to understand the consequences of your design. Sometimes it's unintended, right? The designers might have thought one thing, but it did not work that way. That's why we want to create prototypes and not just evaluate it ourselves, but also take it to different kinds of people and say, hey, what do you think about it? And again, it's also encouraging people to question things. Right? Question like, hey, what about the climate? What about these elements? Have you thought about the life cycle of it? Have you thought about how it is going to be disposed? You want to encourage people to ask questions because you may not be able to think about all the questions, right? We are, of course, human. Our experiences are limited as well. But when you encourage people to ask questions, you can find things that you haven't thought about before. And the intent is to not, when you go and ask people questions, it's not to find answers for those questions. It's more importantly to find answers for questions that you did not know existed, right? So the more important thing is the mindset again. When you take your prototypes, imagine that you are in love with your prototype. You don't want to hear anything bad about it, right? So even when people say that some comment about, hey, you want to think about this one, you may miss that. Not intentionally, you may not hear it the same way. Because people are sometimes they see the joy in the prototype that you have shown, right? They may not want to hurt your feelings, or they may say, hey, this looks very good, nice job, keep it up, right? But you should ask and probe, hey, what are the things I haven't thought about? And you should probe people. Sometimes it's encouraging to have 2 different prototypes instead of 1, because it can be a conversation starter. You can ask, which one do you like more? What do you think the advantage of one is over the other? And the iterative step helps quite a lot, right? So you make 5 different prototypes in the first round, imagine. You go through the cycles and you learn more and more, and you redefine the problem every time you go through it. So your what do they need and why do they need can continuously change as you explore the project.
Thank you.
Does that address perhaps some inkling towards what could be done?
Yes, it does. Thanks for emphasizing that.
Good. Any other questions?
Maria, back to you.
Thank you, Ravi, so
pleasure.
much. Thank you, Renee.
Thanks,
also,
everyone.
We're gonna jump into FishTank questions, but I just want to thank everyone for being here and listening to the presentations, and hopefully come away with understanding that process is magic. I love that. I'm going to use that all the time now because it gives you your map of how to get somewhere, even if you don't know what that end looks like yet. And that when you keep trying, you keep asking questions, you'll find more things that help people who really need the help, but then also that there are other people that are there with you trying to solve the problem with you. So thank you so much.
Thanks again. I appreciate it. Thank you, everyone. Bye. Bye.
Aloha.
Aloha.
Okay. FishTank competitors, it looks like thank you for continuing to stay with us at the events that we're providing before the competition starts. Majority of you have registered already for information. So I'm going to encourage you to also register for our competition. This is where we're going to, or you're going to let us know who you want to work with, who your team coordinator is. And if you don't have one, a team or coordinator yet, register anyway. We'll do our best to help you find one. I'm going to break down real quickly again the key things about our competition. We start in December. Our registration deadline is December 3rd, and then we start our first workshop December 10th. We'll send out a schedule with dates so you can save those on your calendar. This competition is open to all grades 6 to 12 on Hawaii Island, and teams work in members of 2 to 4 members, and they're supported by a team coordinator. All workshops will be virtual. There are only a handful of them when the competition starts, but there'll be check-ins with the teams and their team coordinators and our subject matter experts. Everything will be on a FishTank website, on our Next Tech website. There's no Google Classroom this year. All the resources will be there, and we're offering a new gallery of subject matter experts where you'll learn and be connected to them during the competition. Again, there's no fee to enter. All of these resources are our team's time. We all volunteer so that we can offer as much opportunities to learn during this competition. There are cash prizes as well. Check out our website. Lots of different opportunities to win cash prizes. What else? Am I missing anything? Let's see. Each team will have a budget of $250 to also prototype. So that'll be really fun once you start getting into that phase of your engineering design process to actually start playing with conceptual models or physical ones.